So, Matt, why don't you start out by saying where you grew up, what high school you went to, and maybe why you came to Cabrillo?
Yeah, so I grew up in Washington State, and then I moved down to Northern California with my family while I was still in high school. And we ended up moving around quite a bit while I was in high school. Um, and so I have to say, this is kind of funny to think back, but I didn't really have a whole lot of interest in school at that time. I didn't see myself as a good student. I wasn't really getting the best grades, but I was doing things that engineers would typically start to do naturally. Like, I was interested in robotics and building different projects. And this is at a time before that was really a thing. We're talking almost 30 years ago, really. So I was going out there and trying to build things and figure things out. I also enjoyed aviation. I spent all my money that I worked at a grocery store. I spent all my money on flight lessons. And so I really liked aviation and I really liked engineering. But as far as, thinking about those two together in school, I never put the dots together. So when I graduated high school, I just went into the work field and I started doing some pretty manual labor jobs, sometimes in pretty hazardous working conditions. So that's why, crawling underneath the house was not really a problem for me. So I mean, I literally worked in hazardous clean on a hazardous cleanup crew. So it was hard work, and all respect to people who do those types of jobs, but I got to a point after a few years where I was like, this isn't really what I want to do for the rest of my life. It's not really fulfilling the interest and needs and those types of things that I want to do. So I eventually decided I would go back to school, and that was a big decision for me because that was kind of the furthest thing from my mind when I graduated. And so I enrolled in Sacramento City College for one semester, and then I had a friend who was looking for a roommate out in Santa Cruz, and they were like, "Hey, you can come out here. I got a good deal for a room." And I'm like, "Oh, Santa Cruz, that sounds like a great place." I was living in Sacramento. Nothing against Sacramento, but I really loved Santa Cruz after I showed up there. And then I found Cabrillo, and I only had one semester of experience at a community college, but I immediately noticed there was something different about Cabrillo. Um, and I didn't really know what I wanted to study, but I thought this is a cool school. I like this. I'm just going to start taking classes. And I actually said this out loud. I said, I'm going to find something that I like that's interesting, but I just as long as it doesn't have too much math. And so that was kind of funny to think about now after looking back, because that's pretty much all I do. But that's where I was at the time. I didn't realize my potential. I didn't realize what the things that I could do. So I think the first class I took there was Math 4. I took another class at Sacramento City College before that, but I took Math 4, which is pre-calculus. Oh, by the way, this is weird. I've done a lot of classes. I've gone to different universities. I still remember almost all the course numbers at Cabrillo for each course, and I think that's funny. So I'll make references to them, and you may not be aware of them quite yet, but you'll eventually get to know them. Some of you who decide to stay at Cabrillo, but anyway, so I was like, hey, this is the thing. I'm going to take it one semester at a time and just see how it goes. And after about two semesters, I started doing fairly well, and I liked it. And I thought, well, I did my math classes, and I can start taking physics. And I intentionally took the engineering physics just in case because I didn't really know what I wanted to do. And it just went from there. And eventually I'm like getting excited about this situation, going, hey, I can do this. I can't wait to take my engineering classes. And I am so grateful for everything that happened at Cabrillo, and it really is a family there. I've got experience at other schools; they're not bad, but they just don't compare. So I'm not putting any other schools down, but this is my own experience, and I got to a point where I really didn't want to leave, but I knew I had to because I took almost every class there was, and this is 3 years, probably 3.5 years, because I'm making up for high school and I don't know what I want to do. So I'm just taking lots of classes, and I was having a lot of fun, but then came the day where it was time to transfer. So um, I remember that time, and it seems like yesterday. I had to decide what major to study. And I chose mechanical engineering because of my interest in aerospace and in mechatronics. And so I applied to a bunch of schools and as a mechanical engineering major, and I ended up going to UC Berkeley. Um,
Matt, do you want to talk a little bit about what the transfer was like to Berkeley? And
yeah,
also, I want to mention that internships are a big part of what we do at Cabrillo, and you
yeah,
did wind up working for my husband, who's a
yes,
mechanical engineer, and you were doing
yes.
work for him, and that was great experience.
That was a great experience. It was hit the ground running. He had the designs ready to go, and I remember my first day helping working for him. We were putting stuff together. I was building electrical panels and just making it happen. So that was
Yeah.
fun. I still have some pictures from the stuff we were building.
Okay, cool. All right, so why don't you talk about Berkeley and your
Okay,
experience? What? Okay, just go on.
so so I didn't really have like the best understanding of like what it was gonna like be to transfer, right? And I was a little bit intimidated because I just didn't really know how things would be different, how things were going to work for me. I will say that that first semester, whether you're going in as a freshman or uh, a transfer student, there's an adjustment. They do things. I'm just gonna be honest. They do things differently at the universities. Okay. Um, I honestly, I'm not putting them down, but it's not as focused on the teaching aspect. Especially, I hear stories about the freshman entry class. There's a lot of like, hey, get through this. You're in a class of 300 students. You don't have the same access to the instructors, and it's kind of it's a bit of a grind, right? So I wasn't really sure what to expect. That first semester, I didn't even know if I was going to make it through. But by the end of the semester, I knew I had this handled. I remember taking my first exam, studying hard for it, and I looked at it. I'm like, "What is this? Did we talk about this?" And I was like, "How is this possible?" I studied everything we talked about, and I'm looking at the exam, and then I'm like, "Oh no, I'm not going to make it. I'm not going to make it. This is terrible." What did I do? And then the test came back, and I see the test score, and I'm like, oh great, 54%. That's not very good, right? And then they go, oh, by the way, the average on the board, the professor writes the average was 42, and you go, oh, okay, 42%. So I'm thinking, well, so I had to learn quickly that they don't like match up the testing, like what they're putting on the test sometimes as well as they could be. I feel like at school like Cabrillo, there's a lot more focus on making sure that that's matching up really well, and you're going to get a natural kind of bell curve distribution right where you want it just by getting the testing right. But it was a shock. After I figured that, I settled down a little bit. I'm like, all right, well, whatever. I'm just going to do it. And so that's what I did. It was 2 years there, and after the 2 years, I was ready to move on and get done with school because you got to think I've been in school for about like 6 years at that point, just getting up to my bachelor's. And I'm like, I need to go make some money. And not only that, I was a little bit older than my peers graduating because I was actually a re-entry student. So I'm like, I need to start making money and getting on with my life here. So that's when I applied to Boeing, and I didn't really apply to a lot of places, but I applied there because I liked aerospace. And so I interviewed, and they offered me a job on the spot, and they moved me and um, my college furniture that I probably got free on Craigslist. It was kind of weird. They packed it all up in a truck and shipped it up here. Probably paid a lot of money for that, and then I got an apartment, and then I started working up here at Boeing, and my wife and I moved up here together. And I've actually been in the same job uh, ever since. I've moved around a lot. One thing to note, I do have some pictures to show where I work and what that looks like. So I'll see if I can try to do that. But um, I've literally been in the same job, even though I've moved around and done tons of different things. That's the benefit for working for such a big company. You can do that, you know. So I'll just show you some pictures of. Hopefully I can get this to work out here. I'm gonna share my screen, and then I'm gonna go over here, and then let me know if you can see this. Can you guys see this okay?
Yep.
Yeah.
Okay. So this is the building that I work in. Um, it's up in Everett, Washington, and we built. This is where the 747 was born. So all the 747s were built. All the 767s, 777s, and 87s are built. It's about 30 miles north of Seattle, and it has the distinction of being the largest building by volume in the world. And I work, well, I says here's my desk here. I don't sit on the roof. I should probably clarify that. I do sit inside the building, but my job's unique because I don't sit in an engineering office. The engineering offices are over here. I don't know if you can see my cursor, but in this area. But I actually work in the factory, which I think is a lot of fun. And so from my desk, this is what I look at. I sit up on a mezzanine, and this is an area most of the parts from the airplane that we build, the airplanes that we build, they come in pieces from all over the world. So a lot of pieces from Japan, Mitsubishi, Subaru, uh, Kawasaki Heavy Industries, so all over the world. And Everett is where we kind of start putting all the major components together. This is the area that I specialize in. It's putting the wings on the fuselage and the fuselage sections together. And you kind of wonder, like, what would they need an engineer in the factory doing? Because I'm not doing any of the initial design work. But when you have such an expensive product, I mean, each one of these airplanes is $350 million, right?
Wow.
And we were building 8 a month. We slowed down a lot right now because we're having a lot of supply chain issues. But we were building 8 of these a month at $350 million, right? So you can imagine, you can't just put stuff together, and if something happens, like you get a scratch, a ding, somebody hits one of these stands on it, and it causes some damage, or somebody drills a hole in slightly the wrong spot. I'm talking thousandths of an inch off, or sometimes a lot more than that, depending on what kind of mistake was made. We can't just throw everything out. You can't throw out millions of dollars worth of parts, like $40 million part or whatever it is. And this is kind of standard across the industry with all airplane manufacturers. So they have a team of quality assurance people doing all the inspections. And when anything doesn't go right per drawing, they have to have an engineer assess it and do the analysis and evaluate what to do. Sometimes that's, it's okay as is. We can deal with that hole in that location. Or sometimes it's we have to change out all of this major components. But it's not something that you can just do without doing all the proper analysis. And I have a special, there's probably 30,000 engineers at Boeing. The company has 170,000 employees overall, and I think a third of them are engineers. In my group, I have 15 team members on my team, but in my class designation, there's only a few hundred of us who actually have the authority to sign off and approve these changes. The design groups, most engineering jobs at Boeing are very compartmentalized. So you'll get people who specialize in landing gear, flight deck, avionics, whatever it is, curtains, lavatories. There's whole teams dedicated to each one of these commodities. But what I love about my job is that I get to deal with all parts of the airplane. So from nose to tail, and not just in production. I also work airplanes in service, and we do flight testing, all kinds of different interesting things. So I just wanted to give you an example of what the product that I work on is a 777. Here's if you've ever flown on Southwest Airlines or Alaska Airlines, you'll be likely flying on a 737 because they're all 737 fleets. That's the airplane on the right here, and you can see the 777 is the one that I work on. It's on the left, and you can see the size difference between the two. And so it's a very big, expensive, and pretty complicated airplane. Now, I got some photos here of some of the types of damage that we would deal with in service. And production issues are one thing, it's like, okay, but when the airplane gets out in service and bad things happen, the problems get really interesting. Now, most of the time, it's hey, we replace out as much as we can, get new parts on there, make it good as new. Keep in mind, everything that I do, I have to make sure that this airplane is going to be safe for 40 years, or meet all of its design service objectives. It's got to meet all its ultimate flight load capabilities, everything. So that's where the real challenge comes. So something like this, we have a Qatar Airways 777 that the pilots accidentally went down the wrong taxiway and they drove the wing into a light post. They unfortunately got fired for them, but this repair wasn't that complicated from an engineering perspective, but there was a lot of parts coming off the airplane. It didn't actually penetrate the wing box. Oh, by the way, I don't know if you know this, but the wings are where all the fuel is carried. So the wings, every airplane, all the wings are full of fuel. So luckily this one, it didn't penetrate it. And we just had to change out the leading edge structure and the slats on that one. Some other times, damn, this one's pretty terrible. It took us months to figure out whether this one was going to be actually repairable. This was an engine fire in Las Vegas on a British Airways 777. GE makes the engines, but they're really reliable engines, and something went amiss on this one, and it caused a fire. And you can see all of the heat damage that occurred. Now, obviously, the stuff that's bad, if we're going to repair this, is going to come out. You can see that it's not good. But the big question from an engineering perspective was how much do you take out? How far do you go? And we did a lot of things, looking at heat tempers and in the heat affected zones. And these are things you will see in engineering 45. You're talking about anytime metals are exposed to different types of heat, you lose capability, you lose strength, you lose durability. There's a lot of things that happen. So this was kind of an interesting one. They, like I said, it took like 3 months of analysis, pulling things apart, testing. We're doing like Rockwell hardness testing, all kinds of non-destructive inspections to make sure that to get the scope and bound of the damage covered. And then what happens then is they send a team out and pack up tools in a freighter with mechanics. They got mechanics, engineers, usually about 2 or 3 engineers, quality people, and we all go down there and set up shop and start working on the repair to get it back in the ground. Because you remember, this happens anywhere in the world. You never know where this is going to happen. They don't necessarily have a repair facility there, so we have to set one up. This one got repaired up enough to safely fly back to the UK where more work was done. And so you can see here, this is where the new skin panel was put on the airplane. So you got a new skin panel. I didn't notice this at the time, but I was looking at this photo. This engine right here is a Pratt & Whitney engine, and this one's a GE. So it's kind of funny. I think this is the one that they had available, but it's okay to do that for a ferry flight back to the other maintenance facility. But this was a very extensive repair. It took a few months to do. Probably cost millions, $10 million at least to do something like this. I mean, it's unbelievable. We've had to have skin panel sections like this shipped in from our suppliers on a emergency notice to do repairs in the factory, and just the freight on it alone was like $800,000. So it's an expensive industry. I wanted to show you this too. Another thing that I do when we're doing these repairs is we have to jack the airplanes, and we don't just jack airplanes, like you jack a car to get the wheels off the ground. We jack them for structural repairs. So if we're going to be taking out a skin panel in this area, we have to do all the load calculations to make sure that when we start taking stuff apart, the airplane doesn't want to just come apart. And so we do shear and bending moment diagrams. And one thing I thought was really cool is they look almost identical to the shear and bending moment diagrams you do in engineering 35 in your status class. And you would think like, hey, this is an airplane. They got to have something super, super complicated. Not really. Actually, it's all fundamental. I mean, the airplane has we have basically a distributed load, and it's variable, right? Of course. And so we know what all those loads are every 21 inches or so. And we put that into an Excel spreadsheet, and we have our major jack points. And this one doesn't have any repair jacks. These are just the service jacks. But we put them into a spreadsheet, and we start moving the jack loads around to figure out how to minimize that shear and bending load at the area where we're trying to do the repair. So I thought that was pretty cool. So I kind of tried to do a little overlay of like a simple supported beam, because it's really what it is. And it only takes 3 jacks to hold this airplane up. In fact, the 4 jack here isn't really needed because the center of gravity's after these other jacks. And so this 4 jack, this whole airplane can sit on just these 3 jacks. In fact, that's what we do in the factory when we test the landing gear. We only put it up on 3 jacks, and then we run the landing gear up and down, and the nose is kind of flopping around a little bit, but it's still safe to do that. Okay, so, and then here's
and that's you saying I should use that example in a statics, huh?
Yeah, I would be. It's cool, and I hope you're still giving out that little cheat sheet with the shear and bending moment diagram curves.
Yep, I am.
Yeah, I've actually been in situations like, man, I wish I had that right now. That's a good one.
I can send it to you.
Yeah, because it's amazing. A lot of things you're going to be learning in school, you don't think they're going to actually practically apply, because you're like, okay, these are just the fundamentals, then I got to go do this. Well, That's true in a lot of situations, but you'd be surprised how many hand calculations I can get and do to solve some of these problems that you think you wouldn't be able to do. Of
Yeah.
course, we have like super complicated computational fluid dynamics and finite element models and all these different things, but there's a lot of things that come down to fundamentals when you're looking at specific things.
Yeah. Hey,
So
Matt.
here's yeah,
Oh, why don't you show this one quick and then I want to, yeah, okay, good. You're going in the right direction. That's what I was going to ask you.
yep.
Why don't you
Here,
just talk about
these
this
are
for
just
a
the
little bit?
repair. These are just the repair cradles that we use to help support the airplane while we're taking it apart. Okay. Uh, how has engineering impacted my life? Well, I really like my job. I don't dread going there. I enjoy it. I have a lot of people that I like to work with. Um, I don't know if I'd still be going there if they weren't paying me. Probably not, but you know, it's been a great career. I've had a lot of opportunities to move around and work with lots of different people from all over the world, and I'm able to pursue personal hobbies and interests. And so it's a decision that I'm so happy that I made to go into to engineering. Um, I know I'm almost out of time here.
This is great.
I was trying to think about some key takeaways. I think I might have enough time to go through them all because I'm
Yeah.
moving fast here.
Yeah.
Okay, as a student, do this. Make sure you always do this. Get a study group. I learned it at Cabrillo. I would sit in the 700 billion Mesa Center or the PLC. I don't know if they're still around. Hopefully. But I would work with other students, and I really felt like a sense of community. And I learned to do that, and I carried that on to my studies in university, and even when I was going to grad school, I was doing that while I was working. But I made sure that before I went to grad school, I found another employee or somebody who wanted to do it too, so that we can always work together, and it's going to benefit you more than you would ever imagine. As far as choosing a transfer school, pay attention to things that you don't think about necessarily as far as the study aspect. Things that are really important. And there were challenges for me at Berkeley where where I lived. I lived in an urban environment. It was super expensive. In hindsight, I probably would have liked to live in a lower cost area, maybe more in a student student environment or a college town. Just things to keep in mind: how far away is family? What's the weather? All those things. Keep those in mind. Um, don't get overwhelmed by looking at all the classes you have to take. Don't that should never be a deterrent. I did that a couple times. I was like, oh no, I don't know if I could do this. This is too many classes. It goes by so fast. You just take it one semester at a time. And then as far as work goes, when you get to the point where you're looking for an engineering job, pay attention to the complete compensation package. I talk to interns all the time. We get them in, and they're like to talk about different offers or new hires that they got, and they're pretty candid. They're open about exactly what numbers their other companies are throwing out. And one thing is though, there's companies out there that they'll give you an offer that's 10 or 15% more than maybe like a company like Boeing would offer, but they're going to want you to work 70 hours a week. And you might be okay with that now, early in your career, but doing that for years after year, it's not going to be a very great situation. In my job, I'm fortunate enough to be I get paid salary 40 hours a week. And then if I work overtime, they're paying me every hour that I work overtime, I'm getting paid for it. And I've always appreciated that. And then um, as
Mm.
far as the industry that you go in, just keep in mind too that there's some kind of geographical restrictions depending on what you're doing. I know that's not as much of a concern with a lot of virtual work, but for example, if you want to do civil engineering, you can do civil engineering pretty much anywhere. You can do it in Hawaii. You can do it, you can do it anywhere in the country. They need civil engineers everywhere. Aerospace engineers, on the other hand, you're kind of relegated to certain geographical hubs, of aerospace industry. So those are just some kind of tips I would think back, and say, well, that would be nice to mention, when you got. I know it might be a little bit down the road for some of you, but keep it in mind.
Matt, I'm really glad to hear about, your transition from schools and what your experiences were, and also that you love your job and that you talked about some of the projects and failures and how you address them. And then these takeaways are the best. Thank you so much, Matt. I do have a question. My records show that you got a mechanical engineering degree. Did you get mechanical or aero?
Mechanical.
Okay, so could you just answer this question? You're
Yeah.
working in the aerospace industry, but you have a mechanical degree. Can you talk
Yes.
about that? Because often I have students who are trying to decide whether they should get an aero degree or a mechanical degree,
Okay. So Berkeley does not offer aerospace in a degree.
right?
Um, and that's a great question because I work with people who have aerospace degrees, but the majority of the people that I work with and the majority of people that I met have mechanical engineering degrees. It's a nice very broad category, and I think your curriculum is almost the same except for maybe instead of vibrations you take another aerodynamics class or whatever it is. There's I think it comes down to probably like four classes that are different. Um, Actually, the one of my coworkers has a civil engineering degree. Another one has an electrical engineering degree. So there's just a lot of crossover. And the thing is the reality is like when you first hire in, they don't expect you to know anything. That's important to know, like because it could be terrifying. Like how no, I'm going to be working on airplanes, and people's lives are at stake here. You don't want to be but you get trained and you get specialized in your field. And I trained for over a year before I even signed off on anything. And then even after that, there's a lot of supervision and auditing to happen. So whether you do civil engineering, electrical, mechanical, at least at least in my industry, from what I've noticed, they don't really. It doesn't really matter. I think the where it would really matter is probably if you want to do civil engineering, and the main thing is because they really want you to take that FE exam for civil. I would recommend taking it no matter what. I kind of wish I did, but if that's where things kind of tend to deviate. But between mechanical and aerospace, I would say they're almost the same.
Great, thanks. Students have been asking questions, but I've been answering them. I hope that's okay.
That's fine.
And
Thank you.
yeah, and Priti, how are we doing on time?
I think we're at the end of time. Um, Not sure if we want to,
Think about all
if
the
students
answers.
have more questions, maybe Matt, I could
Yeah.
collect them and send them to you to
Yes.
respond because Keiko has arrived.
Okay. Great. That and if send me the questions, I'll answer them. And also, if you have any students who want some more information, I'm happy to help. Just whatever it takes. So I don't want to
Great.
take up any more
And
time. I appreciate. Thank you.
cool. And Priti, do you remember if Matt is on our Engineering Alumni Association LinkedIn page? Matt, are you?
I don't know. I haven't. I got to log into LinkedIn. It's been a while.
Okay. Do you use Facebook?
I do. I have a Facebook account. Yep.
Okay, so look at both of them and join the Cabrillo Engineering Alumni Association.
Okay.
Okay, great. We're gonna have a big party in the summer.
Oh, awesome.
Okay, great.
Okay.
Hey, thanks, Matt.
Thank you.
Thank you, Matt. Um,
Okay, so Keiko.
Keiko, are you here? Let's see. How do maybe you can
I needed to unmute. Hi, I'm Keiko.
Oh,
Pretty.
wow. So
My goodness,
Keiko.
Joanne.
Oh my God, it's so amazing
Oh
to
my God,
see
so long no see.
you. So Keiko was one of my first students at Cabrillo. The person who started the engineering program at Cabrillo in 1961 was Rich Hart. And then when he retired, I took his place in 1995. So Keiko was a student of Rich's and of mine. And Keiko, it's so nice to see you.
Oh,
And
it's so
I
nice to see
I
you.
hope that you do come to the alumni party because I really want to give you a hug.
Oh, yes, virtual hug for now.
Okay. Okay, Keiko. So thanks so much for
Okay.
joining our class. And maybe you could start out with where you started out, where you lived, where you went to high school, why you chose engineering, and why you chose Cabrillo.
Sure. So let me share. I have a little presentation, and let me know when you can see it.
Yep, I could see it.
Okay. So, first off, my name is Keiko Endo, and Matt, thank you for your presentation. It was very exciting because I also majored in aerospace engineering, and I totally agree with Matt that it's although my degree or my diploma says aerospace engineering, it's a hybrid of mechanical and aero. And then for mechanical, I did finite element analysis. So, anyways, I am so honored to be here today, and thank you, Joanne and Pretty, for inviting me to speak to the Engineering 5 class. And I'm excited to share my own story with you and hope to inspire some of your engineering journeys. So, today, in this talk, I will share my personal journey from career to engineering, including my setbacks. And then I will offer my perspective on engineering education and some career tips that I found it helpful. And I attended, as Joanne mentioned, I attended Cabrillo from 1994 to 1995 for 2 years. Oh my gosh, I'm getting old. Okay, so I first like to start from this phrase, connecting the dots. So on June 12th, 2005, Apple's founder, Steve Jobs, he delivered a famous speech at Stanford's commencement ceremony. And one part that particularly resonated with me is his story about connecting the dots. So when he looked back, what seemed to be a series of unfortunate events all connected and paved his path. So I found this to be true in my own journey as well. And moments of uncertainty later became stepping stones to where I am today. The personal journey into engineering. I was born and raised in Japan, Tokyo, Japan. This is the picture that I personally took, a picture of Mount Fuji. And then you can see it has Mount Fuji has a reflection on the lake in front of
Go.
it.
And
Yes.
I could only see the first slide still.
Oh,
So
oh,
let's
oh,
see.
oh. Is it lagging?
Maybe, maybe.
Hmm.
I just see the
No,
slide that says Dear Engineering 5 students.
Oh
I think
no,
it just
really?
has an
frozen.
advance. I think it's not in slideshow mode, so you'll have to go to the left side and
I
move down on
see.
your slides.
Let me see. Okay. So I'm gonna share in a different way. It is in slideshow
There it
mode.
is. There it
Okay.
went.
Okay. So
All right. So
I'm not, okay. I'm
why don't
gonna
you just
stop.
go through them because I'd like to see what the first
Yes.
ones were.
Sure. So I'm gonna just not put into play mode, but I'll just go one by one. Okay. So personal journey into engineering, engineering education and career tips. And then my intro, I just wanted to say thank you, Joanne Pretty, for having me here. And then this is the part that I mentioned, connecting the dots. And this is a presentation or a speech, a famous speech done by Steve Jobs to Stanford's graduates. Then personal journey into engineering, and this is the picture of Mount Fuji and the reflection on the lake. And it's known that if you can take a picture of Mount Fuji reflection on the lake, it's good luck. And so I was born and kind of raised in Tokyo, Japan. But when I was 4 years old, I moved to Detroit, Michigan because of my father's um, assignment. So he was a nuclear physicist and was assigned to Enrico Fermi Nuclear Generation Station near Lake Erie in Michigan. This was in the 70s. That's my dad walking around in the control room. You can see all these cool obsolete machineries in the control room. And then this was my first time in the Western, like a country. And then this is my first encounter with the Santa Claus, and you can tell I was horrified. And But nonetheless, I had a very good experience, learned English, and then just had a blast. And attended elementary school, grade school, in Michigan. Then I returned to Japan for high school. I'm sorry, junior high school and high school education, and came my first setback. So in Japan, there's this entrance examination to all high schools. It's like SAT, but you have to take specific exams to get into specific school. And then there was this like science-oriented high school that my brother went. He's a mechanical engineer, and but I couldn't get into that. I couldn't pass the exam, and then I did play the piano, not that great, not that serious, but because of some dumb luck, I got into this music high school. So couldn't get into this really nice scientific high school, but I ended up in a music high school. But it was some kind of a dumb luck getting in there. I became a music major dropout and had to give up that path. And then I thought, okay, I like animals, so I want to become a vet. So I went to Oregon State University, which has a pretty good reputation of veterinary medicine school. But I underestimated it, and I also dropped out of the vet program. And then my counselor back then said, "Oh, I can't make it in this vet program." And then he goes, "Well, do you like math?" And I said, "I love math." And then he said, "Then why don't you go into computer science?" And then I said, "Okay," because he said, if you want to get into biology, if you want to get into medicine or medical or any field, from now on they are gonna need computer science, even business, whatever. Computer science, it's like a Swiss Army knife. And so I did. And then I earned a computer science degree without the internet, so you can trust me. And I plan to wear this t-shirt at my retirement party, but I can't retire for some time because my two daughters are still in high school. Then what happened was, okay, so computer science is a science that's made by human. So there are like flaws and mistakes and bugs. And I was really fascinated by natural science, like physics, chemistry, and so forth. And then my dad being a nuclear physicist, my brother, mechanical engineer, and also my roommate at Oregon State was a mechanical engineer whom I still keep in touch with. And so I had this thirst for natural science. And that's when I started to attend Cabrillo College in 1994. And this is a real Chem 2 notes that I took at Cabrillo from 1994. And I was so fascinated because back then, Roderick Oka, I'm not sure if he still teaches there, but Roderick was our instructor. He was amazing, if not as amazing as Joanne. But this, he explained polar head. The soap has a polar head and a non-polar tail, and the grease is non-polar. So all the tails get attracted to grease. The soap's non-polar tail gets attracted to grease, and then water is polar, so it carries, the soap carries the grease off your hands when you wash your hands. And I thought that is fascinating. And yes, this is natural science. So then I transferred to San Jose State. And Matt, I think you really know about this, but my fourth major, raised to the power of two setback, was I couldn't work in the aerospace industry because I did not have the citizenship, US citizenship. And so I did get US citizenship later, but meanwhile, I went back to computer science. And then I'm like, oh my, I was devastated because all this work to get a master's degree in aerospace engineering, and then I can't really use it. What's up with that? And then went back to computer science, but that landed me a job at Apple, which was the best thing that ever happened to me. Well, not the best, but one of the best things. And so aerospace engineering, and but I don't like regret a bit. If I have to do it all over again, I'll do the same thing because I love natural science. I love, mechanical engineering, aerospace engineering, and the time that I spent at San Jose State. I'm sorry, I meant to say San Jose State and Cabrillo College. It's just really precious, a precious memory to me. And then the next, I like to go into engineering education and career tips for building your foundation. I'm not sure if I can play and you can see it or not. If you cannot, let me know. Are you still on the builder foundation slide or not? Okay. And then if I do
Yes,
like
we
that,
are.
okay, did you see college algebra come down
Yeah.
as
No,
animation? No,
no, I
okay.
did not see an animation.
Okay, got it. Then I will go back to, I will get out of this. And so what I wanted to, it had a little bit of a animation here, but my recommendation, and which I did at Cabrillo, I built my foundation. It's same for chemistry, physics, math, static, whatever. It is super important to build your foundation from college algebra, pre-cal, and trig. Math 5A, 5B, 5C, they are super important. Linear algebra and differential equations, DiffQ. And then once you have built this foundation, you're ready to take college classes like numerical analysis, applied linear algebra, partial differential equations, and mathematical modeling, and so on. There are like so much more. But I highly recommend that this green part becomes your muscle memory.
Mm.
And then as for career tips, I think it's really important to keep learning. There are after you graduate, there are a lot of programs that perhaps your company offers. And then also online courses like Coursera and online courses from various universities. But a cutting edge technology today could be completely obsolete next year. So I think it's very important to keep learning and also strengthen your soft skill sets. So that is like in a meeting, make sure you can clearly communicate what you're trying to convey, presentation skills. And then one thing is to your client, you have to, many times you have to say no to your client, but just not saying no, you want them to say no. So you have to convince them, okay, this is why you don't want to do this. And then, so they said, and they think about it and say, yeah, you're right. I don't want to do that. And so, soft skill sets like that, I think it's super important as well. And then, lastly, I'm going to go back to my setbacks. So, in conclusion, my first setback, not being able to get into the high school I really wanted to attend, and I became a music major dropout. But I met like really, really, precious people. Like her name is Yoko here and Akiko here. They're both pianists, and when I go back to Japan, I get to go to their recitals. I met them when I was 16, and we still keep in touch. I'm gonna travel to Japan later this month. I'll get together with them when I go home or go back to Japan. And then they just enrich my life just beyond belief. So that was the really great thing that came out of my first and second setbacks. And then I am a vet program dropout, but that led me into computer science. And then that allowed me to really land a job at Apple. And then who knew? Now, internet is really like involves satellites. And so I did study like orbital mechanics. I did do an intern at Lockheed Martin, although I couldn't become a full-time employee because I didn't have citizenship back then. But now different disciplines are getting together. And so who knew? Um, all these setbacks became my stepping stones and led me to here. And then, so that's why I love this phrase, connecting the dots. Thank you.
So Keiko, could you tell us
Yes.
a little bit about projects that you've worked on? So have you been at Apple the whole time?
No, I actually started as a um, programmer or a software engineer, and then also utilizing my background in Japan, and then like a Japanese Asian language, and then English. I modified source code that only worked in English operating systems back then. Now, if there's Unicode, and then everything works flawlessly, but back then you have to recode so that it will work on different platforms. So that's how I started my computer science career. And then went into like international, so that's called internationalization, modifying code so that it will run on different platforms.
Oh.
And then um, there's this product. I was at a startup company called Uniscape back then, and then Uniscape had this product called World Server, which is to localize localize like a content in English into various languages. So I'm not sure if you saw a this launch that was delivered on Monday for the new for the iPhone and things like that. But anyways, so that content material for marketing, sales, training, and so forth, they're all localized, translated into different languages because we send our products all over the world, and it was translated into 141 languages. And so that world server is being used, and then I was pulled into Apple to migrate a vendor system that's at the vendors or the company that I used to be data center to Apple's data center, a lift and shift migration. So that's how I joined Apple. That was 14 years ago. So yes, I worked at different companies, but it's those that's pretty much the highlight of my path.
Yeah, it sounds really interesting. And because you had the language, and there are students in the Engineering 5 class that know different languages too, it's
Mhm.
another advantage for you that sets you out among your peers who may only know English. So that's really awesome.
Thank you. And then also I want to mention that at San Jose State, I had this for my thesis. My advisor, Kevin Sawyer, that's his Dr. Kevin is Sawyer is his name. But I ran into him at Apple. He specialized in lenses, and then at iPhone lenses. And then I just ran into him and was like, "Oh my gosh, Kevin, what are you doing here?" And so it's not just a software company, but it has environmental engineering. It's like it has pretty much, different disciplines. So it's kind of nice that you can apply to different divisions or organizations within the company.
Yeah. And one of the students asked a question when Matt was speaking about the difference between small and large companies. And you're both working at large companies. And Keiko, what you're mentioning is when somebody thinks of Apple, they think, oh, they hire computer engineers and programmers, but they're hiring, just like you said, many different types of engineers because there's so many different divisions. And
Exactly.
that's the same thing with Boeing. And I
Mhm.
mentioned also in the chat in answering the question that one of our classes in Engineering 5 is devoted to engineering industry and employment and professionalism. And our teacher, Arlene, has worked, as her degree is in mechanical engineering, and she's worked for many different companies in the Bay Area, and some are small, some are the large. And she'll have, she'll be able to share that experience with you, what the advantages are of both. Um,
Mhm.
and then it looks like somebody wrote in the chat, Kellen, is that how you pronounce it? Kellen? My wife is actually, well, why don't you read it? Tochiki, is that how you pronounce it? I'm sorry, I don't know.
Tochigi, yes, it's Kellen as well.
Oh, Kellen, why don't you explain it?
Oh yeah, so actually my wife is from Japan. She just immigrated here with me after I lived there for the last 4 years. So do you know where specifically you were in Tokyo when you were a little kid?
Yes, so Komae is it's close to Kanagawa Prefecture, but it's within Tokyo, but it's a residential area, probably about 20 minutes on Odakyu line from Shinjuku.
Okay, it sounds familiar, but
Uh-huh.
I can't see the exact location in my head, but
Yeah.
Where did you stay? Where did you live over
uh,
there?
Tochigi.
Tochigi.
Yeah,
Okay, Kanto area. Got
yeah,
it.
yeah.
Cool. So we still have
Cool.
some more, a little bit more time. Other questions? Matt, you might even want to ask Keiko a question.
Yeah, if there
Or
are
Cliffy.
questions from the class, you have the option to unmute, or you could type it into the chat and we could read it out. So, and Matt is still here, so you could ask Matt or Keiko any questions.
Okay, so Christopher said, what skills do you think are most important for an engineer? Keiko, you want to start?
Okay. Really what you learn at Cabrillo, physics, math, chemistry, and then statics, all the classes that's necessary for engineering associate degree. I think those are the really the tools that you will heavily use after you transfer.
And Matt?
Yeah, I think I agree 100%. And the real thing is you're learning specific subjects, but you're learning how to solve problems. There's a process to that, to make sure that you're going through the necessary steps. And sometimes it seems a little bit like you have the solution. It's like, oh, that's easy, we'll just do this. But there's a process that you have to work through as an engineer in order to make sure that you're addressing all of the issues and all of the things and make things come together. So having those fundamentals, learning how to solve those problems really sets you up really well for solving other types of problems in industry, in my opinion.
All right, and Samuel asks, is it beneficial to go beyond a bachelor's degree?
Think so. I never did PhD, only up to master's degree, but I don't know. Like it depends on what you want to do. A lot of companies will really value the time that you spent in the real industry and with the real work. They really value that. And so it depends on like the major as well. But I don't, regret getting a master's degree. But what do you think, Matt? I really think that real experience is
Yeah.
what is valued, and you can always go back to masters or beyond. You can enter a company first,
Yeah.
join a company, and then go back
Yeah,
if you
that's
see
exactly
the
what I did.
need. Hmm.
Yeah. I went in, Boeing paid for, big companies, especially, they'll pay for your education. 10 years after, I think, graduating from my undergrad, I started doing my master's program. I gotta be honest, I didn't see any changes in my career at Boeing for that. I didn't get a raise. I didn't get anything because I was already kind of leveled up pretty high by that point. I did it for myself, and I did it in case, maybe one day I want to go teach or do something different, or I just didn't want. I want to make sure those opportunities were still there, and that's the reason I did it.
Yeah.
But most of the time, it's time in industry. I think is as far as what companies are looking at. That may be totally different for a small company or startup, but that's what my experience is.
And your comments really go to the next question. So Zaid says, did you guys get into internships? And if so, what type?
Yes. So I'll go first. So I did have an internship at Lockheed Martin in the aerospace industry, and then they gave me a project, and that became it was about the next generation space telescope that I analyzed from a finite element analysis perspective, and then that was a great experience, and that became my thesis to graduate. Mm-hmm.
And Matt?
I did not do an internship, but I wish I did. I meet with a lot of interns. We do paid internships. They pay them pretty well. And they from the response that I get from them, their experience is really great. And it's just such an awesome thing that you can do if if you have the opportunity to do it. Especially when you start looking for different jobs after you graduate, you have that one more data point of what to expect.
Yeah. And you get to see from internships, you get to see what kinds of companies you like to work for or don't, and the type of work that you enjoy and don't. And with the skills you're going to receive through the engineering classes at Cabrillo, you could get an internship. So look at Prithvi, maybe I think you're having Christina and Lauren come to the engineering education class, but you
Yes.
guys should look at the engineering department website, and there's on the left-hand side, it says internships and scholarships, and go to that page. And it talks about all the different skills that you get from each one of the engineering classes. And it tells you which classes give you the most skills for each engineering field. And Matt, I would say that the work you were doing for Jamie would be considered an internship. It may
Yeah,
not be
that's true.
like, yeah,
I wasn't thinking about as a formalized internship. That
yes,
was a really great opportunity. I've actually taken some of those skills, and done other projects outside of Boeing using those skills. And so yeah, I technically I did have an internship, and I had a lot of a lot of good time doing that. And that would have been a great thing, as far as putting that on my list of experiences. So
yeah.